Hello everyone, welcome back. Today we are going to learn real numbers class 10 exercise 1.1 question number 4. Now let's read the question. Use Euclid's division lemma to show that the square of any positive integer is either of form 3m or 3m plus 1 for some integer m. Now let's read the hint. Let x be any positive integer, then it is of form 3q plus 1 or 3q plus 2. Now square of each of these and show that they can be rewritten in the form 3m or 3m plus 1. In this question, let's begin the solution. In this question, we will take a as any positive integer and b is equal to 3. Now we will complete this question by using Euclid's division lemma as it is given in the question. So I will write this by Euclid's division lemma. So what is Euclid's division lemma? It is nothing but a is equal to bq plus r, where r can be equal to 0 and is greater than 0 but lesser than b. Now we have b as 3. So we'll take the possible values of r can be 0, 1 and 2 because it is less than 3. Now we'll take r is equal to 0. Now a is equal to 3q plus r. B is 3. Now we'll take a as r as 0. Now we will get 3q. Now in this question we have to square these numbers. Now let's square these numbers. Now this is a square and this is 3q square. 3q square is nothing but 9 square. So 9q the square. Now here we will take 3 as common in this. So 3 3s is 9. So we'll write down 3 and in the bracket 3q. Now in this bracket this can be written as 3k1. I will say you in last that what is this k1. We'll take r is equal to 1. So it will be a is equal to 3q plus 1. Now here we have to square this. So square plus 3q plus 1 the whole square. Now this is in the form a plus b the whole square is equal to a square plus 2ab plus b square. So now we'll use this formula. So I'll rub this. So now this a square is equal to 3q the whole square plus 2 3q and 1 plus 1 the whole square. Now this is we used that formula and wrote this like this. Now we'll continue this. 3 3s is 9. So we'll write 9q square plus 3 2s is 6. 6 into 1 is 6. So we'll write 6q plus 1. So now here I'll take 3 as common because 9 and 6 comes in 3 table. So I took 3 as common. 3 3s is 9 and 3 2s is 6, and here plus 1. Now this in this bracket can be written as k2 plus 1. I'll rub this. So next we'll take r is equal to 2. Now this might be tricky. Please see this carefully. So now a is equal to 3q plus 2. Now we are doing the square. Is equal to 3q plus 2. Now this is also in the form a plus b the whole square, where a is a square plus 2ab plus b square. So we can write this down as 3q square plus 2, 3q, and here 2 plus 2 square. Now 3 square is nothing but 9q square, and 3 2s is 6, 6 2s is 12. So here 12q plus 4. Now here there is no common. So I'll write 9q square plus 12q plus, now I'll split 4 as 3 plus 1. As 3 plus 1 is 4. Now I'll draw a line. I'll continue my sum here. So now I'll take, here we can take 3 as common. As 3 3s is 9, 3 4s is 12, now 3 1s is 3. So now I'll write 3 as common. 3 3s is 9, and here 3 as common means this is 4. So 4q plus 1, and here in the bracket plus 1. So now here in the bracket I'll write this as k3 plus 1. Now I'll say, now here k1, k2 and k3 is nothing but, I'll write it down here, k1, k2 and k3 are some integers. Now here there are some integers, means in the question it is given that m is also some integer. So where this k1, k2 is k3 is there, we can write that place as m. So this is our first sum. Here k1 is there. So I can write it down here is 3m, and here 3m plus 1, and here also 3m plus 1. So it can be 3m or 3m plus 1. So we can conclude that square of any positive integer is in the form of 3m, 3m plus 1. Now this is our final answer. We had to prove that 3m or 3m plus 1 is the square of these numbers is in the form 3m and 3m plus 1, and hence it is proved. If you like this, please subscribe our channel.